Good afternoon. My name is Matt Oneal, and this is my LUT1 presentation with Western Governors University. Today we're going to discuss the Cretaceous-Tertiary mass extinction and discover not only what caused this event to happen, but how severe the effects of this event were on life at the time. Now imagine, if you will, a scene of devastation. Wildfires roaring out of control in every direction. Smoke so thick it hurts to breathe. A constant rain of acid, ash, and debris all around. And 50% of all life on the planet is dead. Now think about that for a second. 50% of all plants and trees, animals and humans, half of them all dead. That's a pretty grim vision, isn't it? That's exactly what life on this planet saw some 65 million years ago. And for some groups, like the dinosaurs, it meant the total extinction of their form of life. Now this event has been well documented in recent years and is most commonly known as the Cretaceous-Tertiary event, or the KT event. Boundary, which stretches over a period of many years, is regarded as one of the 5 deadliest mass extinctions in Earth's long history. According to Cohen, at least 50% of all life became extinct during this brief period of time. Now naturally, the biggest question that accompanies any discussion on the topic is, what caused it to happen? And the answer, as you might have guessed, is not a simple one. But there are several theories in existence that have substantial scientific evidence to support them. We're going to talk about a couple of those here today. Now it's likely that there were actually 2 massive events that occurred at the KT boundary on opposite ends of the planet. Now one of these events was the impact of a large meteor into the Earth in the Yucatan Peninsula, just off the coast of Mexico. The other event was the heightened flow of lava at the Deccan Traps, which is a large volcanic system in India. The discovery of the Chicxulub crater and the evidence supporting activity at the Deccan Traps suggest that these 2 events are the primary triggers for the Cretaceous-Tertiary mass extinction some 65 million years ago. Now first we'll look at the impact event a little more closely. The original theory is based off the work of a team of researchers led by Walter Alvarez in 1980. Now they found a significant increase in iridium, an element that's not naturally occurring in Earth's crust, but scattered throughout the KT boundary. Now this metal is much more commonly found in extraterrestrial bodies such as meteors and comets. So this led to the theory that a large meteor, large enough in size to scatter iridium across the globe, must have impacted the planet sometime around the KT boundary. Now at the time this was simply a theory, albeit a very compelling one, but a few years later a smoking gun for this theory was found. The impact crater, which was discovered in the Yucatan Peninsula, is situated near a village that bears its namesake, Chicxulub. The resulting crater is approximately 180 kilometers, or about 112 miles in diameter. To give you a rough idea of just how large that is, the state of West Virginia at its widest point is about 130 miles across. That's only 18 miles wider than the Chicxulub crater. Now scientists have estimated that a meteor approximately 6 miles in diameter caused the egg-shaped indentation in the Earth. According to Cohen, the amount of energy released during the impact approximates to about 100 million megatons. To give you an idea of how much energy that is, the Hiroshima bomb of 1944, which devastated Japan and was responsible for about 100,000 deaths, released a mere 18 kilotons of energy. The Chicxulub impact would have released about 5.5 billion times that amount all at once. The resulting fireball from this impact would have eradicated any form of life within hundreds of miles from the site, and debris would have rained down as far away as the state of Colorado only 15 minutes after impact. The intense smoke and ash would have caused wildfires to spread rampant across the western hemisphere, and the resulting plumes of smoke would have coated the atmosphere for many, many years to come. But would this meteor, as devastating as it was, have enough power to cause a mass extinction event on the other side of the planet? It's possible. But there was another event that was already underway on the opposite side of the globe, which may have crippled the Earth's ability to sustain life long before the Chicxulub meteor arrived. And this event is the eruption and steady flow of lava from the Deccan Traps. The site, located in modern India, was once an area covered by a massive lava flow that stretched over 600,000 square miles. To give you an idea of just how large an area that is, imagine the states of Washington and Oregon both completely covered in lava. According to studies at Oregon State University, this event produced over 512,000 cubic kilometers of basalt and volcanic material. To put it in perspective for you, the Mount St. Helens eruption of 1980 produced a mere 1 cubic kilometer of volcanic material. Now what's so unique about the Deccan Traps, aside from its massive size obviously, is the fact that the eruption of this lava was not violent like most volcanoes, but it was a constant gentle flow that stretched over a period of millions of years. The highest point of activity, which is estimated to have produced more than 80% of the lava from the traps, climaxed between 65 and 60 million years ago, which is perfectly aligned with the KT boundary. The exposure of this much lava to the atmosphere would have caused a tremendous effect on the ozone and the air content in the area, and massive lava flows would have caused wildfires to spread, adding even more smoke to the already dire conditions. Deadly sulfur gas would have claimed the lives of much of the animal life in the immediate area, and the acid rain would have killed most of the plant life as well. But perhaps the scariest thing about the Deccan Traps is the fact that the Deccan plume is still active today. It currently lies under the island of Reunion, which is about 585 miles east of Madagascar in the Indian Ocean. Now this time, if I could direct your attention to the chart here, we'll look a little closer at some of the species involved in the KT extinction. Now, as I mentioned earlier, the overall extinction rate was approximately 50%, but as you can see from the chart, this varied greatly from group to group. We'll look at a couple of these here. This group here, which suffered 100% extinction, this is the obvious one. This is the dinosaurs. No member of the non-avian dinosaur family survived past the KT boundary. This other one comes as a bit of a shocker. This is sharks and rays. Now, obviously, sharks and rays have made an evolutionary comeback since this point in time, and it's possible that a handful of these creatures may have survived the boundary and repopulated, but to date, no fossil records of species found before the KT event have been found after the event. Some of the other groups that were hit pretty hard, we see marsupials here with a 91% extinction rate. Snakes and lizards suffered approximately 2/3 when extinct during this time period. And oddly enough, there were some groups that maintained life fairly well through this time period. We see turtles here with only a 12% extinction rate. Monotremes and mammals with only a 5% extinction rate collectively. In closing, the Cretaceous-Tertiary mass extinction was easily one of the most devastating events in the history of the planet. Today we've examined how the meteor impact at Chicxulub, as well as immense lava flows at the Deccan Traps, have contributed to an extinction of over 50% of life on the planet during the KT event. Our current estimates suggest that biodiversity took nearly 10 million years to completely recover following the KT event. This event definitely altered history, but it allowed for mammals and humans to climb to the top of the evolutionary chain. At this time, I'll field a couple of the audience questions.
How did certain species survive the KT event while others went extinct?
That's a good question. It mainly has to do with size of the creatures as well as location of their habitat. Smaller creatures, such as your monotremes and mammals, would have been able to burrow and get into hiding areas to get away from the fires and the acid rain, whereas larger creatures such as dinosaurs would have had a harder time trying to seek shelter during this time period. There was also a food scarcity immediately following the KT boundary. Smaller animals such as mammals would have been able to find enough sustenance to survive, while your larger creatures, your dinosaurs, would have had trouble finding enough food to survive during this time period.
Okay. Has an event like this ever happened before the KT extinction, and could it happen again?
There have been at least 20 extinction events during the history of the planet that we know of. 5 of these events are classified as mass extinctions. That would be more than 50% of all life at the time went extinct. Even though the KT event was the most recent of the big 5, it is not the deadliest. The Permian-Triassic extinction, approximately 250 million years ago, was responsible for 90% of all life on the planet at the time. Now, as far as could this happen again, some believe that the 6th mass extinction is already underway. Current estimates suggest that the current extinction rate today is approximately 1 species every 20 minutes. Now, this is a pretty alarming rate, and it makes it clear that changes need to be made and to ensure our way of life, or else we could be sitting in the middle of a mass extinction with over 50% of all mammals extinct in as little as 300 to 400 years. Any more questions? If that's all, this concludes my presentation today on the Cretaceous-Tertiary period. I'd like to thank you all for joining me, and have a good evening.